Here we'll be solving a very algebraic sounding puzzle using geometry, but not just geometry, parametric geometry. The puzzle is something like this, that a milk truck is en route to make a delivery, while the driver unscrupulously takes out 400 liters of milk, sells it off and replaces it with 400 liters of water. And he does that 2 more times before he makes the delivery. But on the delivery, the vendor finds that it is not milk, but it is a mixture. So he detects that the water to milk ratio in the tanker is now 271 is to 729. And we are asked to find the quantity of pure milk that the tanker started with. Let's start solving this problem. So I'll take this milk axis varying from 0 to whatever quantity of milk we want. And this is the milk tanker from which the theft is occurring. We'll be plotting a water axis like this. So this quarter plane, the first quadrant, will now be able to represent any composition of milk and water that is possible. But of course the tanker doesn't have infinite capacity. So I'll be drawing this line that represents the volume of the tanker. And the equation of this line is water plus milk equal to constant. That constant is volume of the tanker. So it is x plus y equal to constant line. Naturally, it will be 45 degrees to both the axes. And whenever the tanker is full, we will be somewhere on this line. For example, this end of the segment represents pure water, and this this end of the segment represents tanker full of milk, and that is where we are at point A. Now, the first theft occurs. 400 liters of milk has been pilfered from the tanker. So from A, we will go to point B on the milk axis. It is still pure milk, but 400 liters less. So let us draw one more line, okay, parallel to the previous line. But if the first line is x plus y equal to V, the volume, this is x plus y is equal to V minus 400. Okay, volume that is less by 400. So whenever we take something out, we'll be moving from this line to that. And when we fill water, we'll be moving from the lower line to the upper one. Okay, so let us show that, filling of the tank again with water. So here we have replaced it with 400 liters of water. Since it is pure water, this line is parallel to the y-axis. Now what is the net result of this? The result of this is some composition like this. The slope of this line is passing through origin. So the slope of this line is y upon x, water upon milk, the ratio. And whenever we take something out, we will be moving along this line now. Okay, whatever quantity we may take out, but we'll be moving along this line. So when we take out the other 400 liters, we'll go from the top line to the bottom line here, and we will be moving along this green line. Naturally, therefore, we'll be at point D, which is an intersection. Let me zoom to that area over here. So we have moved from C to D because of the second theft. Now, again we replace it with water. So we are going to move from this lower line, the pilfered tank line, to the full tank line, okay, in the vertical direction, pure water direction. So we are at E now. What is the net result? Again, a different composition. So I'll connect point E to the origin, and the slope of this line now, OE, would represent water to milk ratio. That is the slope. What happens next? Of course, one more theft, which will take us from the full tanker line here to the pilfered tanker line there, and we'll be moving along this composition. So it is point F now, at which we are, the intersection of these two lines. From F, we'll again move vertically up, that is filling of water till we hit the full tanker line. And then we'll have a composition that is the slope of line OG. Now how much this slope should be? That has been given to us. And that slope, the target slope or target composition, is 271 upon 729. That is a water to milk ratio. So let's draw a line with that slope. So now we have two lines, a line that represents our target or ideal or given slope or given composition of water and milk, and the line that we have arrived at using an arbitrary assumed volume of the tanker. Now the slope of these two lines has to match, and that is where parametric geometry helps us. Parametric geometry is called as dimension driven design in MicroStation, and it allows us to take a geometric diagram like this and move it any which way we want while retaining selectively certain relationships. For example, suppose I take this diagram and move it here. But I have kept these two lines parallel to each other and the distance between them in the horizontal direction to be 400. Now that is not going to change whatever or wherever I move this diagram to. Okay, so that is the power of parametric geometry or dimension driven design. So I'll take hold of this line OG and move it till it lies exactly on top of our ideal line like this. And now the problem is solved. The two slopes have matched. All that remains is measuring the distance from O to this full tanker position A, and that will give us the volume of the milk the tanker started with, 4000 liters.